Hello everyone, welcome to Anonymous World. Hope you're doing well. So today is day 19 of Advent to Cyber 2023. So let's get started. So day 19 is memory forensics, crypto miners in volatility. So the elves are hard at work inside Santa Security Operations Center, looking into more information about the insider threat while analyzing the network traffic log. Blue discovers some suspicious traffic coming from one of the database servers. Okay, so learning objectives, understanding what memory forensic is and how to use it in a digital forensics investigation, understand what volatile data and memory dumps are, learn about volatility and how it can be used to analyze a memory dump, and learn about volatility profiles. So, first of all, what is memory forensics? It is also known as volatile memory analysis or RAM forensics, which is a branch of digital forensics. It involves the examination and analysis of computers' volatile memory, which we also know as RAM, to uncover digital evidence and artifacts related to computer security incidents, cyber crimes, and other forensic investigations. Okay, so memory forensic focuses on the program that were running when the memory dump was created. And this type of data is volatile because it will be deleted once the computer is turned off. Okay, so what is a memory dump? It is a snapshot of memory that has been captured to perform memory analysis, and it will contain data relating to running processes captured when the memory dump was created. And what is the benefit of doing memory forensics? It offers valuable benefits in digital investigations by capturing real-time data from a computer's volatile memory, like all the processes running at that particular time, and it can provide rapid insight into ongoing activities, detects stealthy threats, captures volatile data like password, and allows investigation to understand user action and what was the state of system during the incidents. Okay, let's go ahead. So what are processes? Process is an independent self-contained unit of execution within an operating system that consists of its own program data, program code, data memory, space, and system resources. Okay, so it can be categorized into two distinct groups. One is user process and another one is background process. So user process are the processes that user has started, which typically involves application and software user interact with directly, for example web browser. And background process, they are processes that operate without the direct user interaction, and they often perform tasks that are essential for the system's operation or for providing services to user processes, for example automated backups. Okay, let's go ahead connecting to the machine. Okay, so we do not need to start a tag box, we can directly start VM, start our machine. We will get a split view. So you can also connect to the machine via SSH. Username and password is given there. So we'll learn about a tool which is known as Volatility, which is a command line tool that lets digital forensics and incident response team analyze a memory dump in order to perform memory analysis. And it is written in Python. It can analyze snapshots taken from Linux, Mac OS, as well as Windows. And it has a wide range of use cases. For example, listing any active and closed network connections, listing a device's running processes at the time of capture, listing possible command line history values like what commands were used, and also extracting possible malicious processes for further analysis, and etc. etc. And for today's task, we will be examining the memory dump for Linux device. And for our convenience, volatility is already installed on the VM. We can look at the different help option using vol.py, which with the H flag. So you can also check out volatility room to know more about this tool and how it can be installed. Okay, let's go ahead. Volatility profiles. So profiles are crucial for correctly interpreting memory dump from a target system. A profile in this tool defines the operating system architecture, version, and various memories specific to the target system. And using the appropriate file is crucial because different OS and versions have different memory layouts and structure. So it comes with many profiles for the Windows operating system, and we can verify this using Vol.py with the info flag. So let's wait until the machine start. So we will run the command along along with this description. Okay, our machine is started. Let's open the terminal. See Vol.py h. So you can see it is working. Foundation Volatility Framework 2.6.1, and these are all the commands which you can use with this tool. So you can see image info, LSA dump, mem dump. So there are a lot of which you can use. Let's see the profiles. Okay, so we need to use info flag. Okay, so you can see a lot of profiles are given here. Like these are for Windows. You can see profile for Windows 7, Windows Server, Windows 2008, and so on. Okay. Did you notice that there aren't any Linux profile listed? So you can see under profiles, these are almost all are of Windows, not of Linux. So profiles for Linux operating system have to be manually created from the same device the memory dump is from. Here are some of the reasons why we typically have to create our own Linux profile. So basically Linux is not a single operating system but rather a diverse ecosystem with many distributions and configurations. So that's why each distribution has their own different kernel versions configuration. So that's why we need to create our own profile for Linux. Okay, and Linux is also open source, meaning its source code is readily available for inspection and modification, which leads to greater flexibility and customization. Okay, so creating profiles is out of scope for this room. So a profile is already in the desktop evidence directory called Ubuntu this file. So let's go there. So right now we are in home Ubuntu. Let's go to desktop, then evidence. Yeah, okay, so this profile is given here, Ubuntu 5.4.0, 163 generic profile. So to use the profile, we have to copy it where volatility stores the various profiles for Linux. Okay, so we need to copy this in local lib Python 2.7 site packages, volatility plugins, overlays, Linux. So let's copy this command. So it's done. Then run vol.py info grep ubuntu to confirm our profile is set. Okay, let's try that. So vol.py info, then we will pipe grep. Let's grep ubuntu. So now you can see it is coming a profile for Linux uh, 5, Ubuntu 5.4.0 generic profile x64. So there is also a link to article which you can read and know how to create a Linux profile. Now let's begin our analysis. Memory analysis. The file linux.mem contains the memory dump of the Linux server which we are going to analyze. This file is located in our home directory. For volatility to begin the analysis, we have to specify the file with the F flag and the profile with the double hyphen profile flag. Okay, so you can use the hyphen h flag to look at all the different plugins we can use to help with our analysis. Okay, so let's start. So you can see linux.mem is given here, our memory dump. Let's clear the terminal. So we will use vol.py. Then we need to specify the memory dump file, which is linux.mem. Then we need to give our profile name. Let's see. So it is done. So these are multiple options which we can use with this our memory file for analysis. Supported plugin commands. Let's see. So you can see a list of supported plugin command is given here, which you can use for analyzing this particular memory dump file, image copy, lime info, Linux API hooks, etc. etc. So we can see the different plugin option that we can use. So let's start with the history file. Okay, now we'll see about volatility plugins. Let's clear this. What we zoom this. Okay, so now we will look at the history file. So the history file is a good place to start because it allows us to see whether there are any commands executed by our malicious actor while they were in the system. To examine the history file for any such command, we can use the Linux underscore bash plugin. Okay, so let's do that. So we will use Linux underscore bash. So you can see the list of commands which were used at the time of creating this memory dump. So sudo was used, then one GitHub repository was also cloned. Okay, bash history, then some home LP folder. Then yeah, you can see MySQL command is also used. MySQL -u root. Then password is also given here. Yeah, so let's take a note of it. Let's copy this. So we will keep it as a note. It might be asked in the questions, or we may use that later. You can see our website is also being called here. Let's see ahead. When performing a cross-reference check with the ELF analyst who was using the server, we identified the following suspicious commands. The MySQL-u root, then p password. Password is redacted here. It was used by ELF analyst, but the cat home lp.bash history command was not. Okay. So this means the malicious actor most likely saw the MySQL command and had access to the database. There is a lot of sensitive information over there. We also identify the curl. This website was also being curled, which the ELF analyst confirmed that didn't use themselves. Okay. So this tells us that a malicious actor used curl to download the toy miner file and saved it using the O parameter as a file name miner. And we can also see that malicious actor executed a miner file using the miner command. So you can see the miner command was also used right after the curl command. Okay. So now that we understand what the malicious actor executed, we can look into the system's running processes. Okay. So now let's see running at the running processes. It is a fundamental and crucial part of analyzing a system memory dump. Okay, because it provides a baseline for what should be expected in a healthy and normal system. So we know that miner program is executed. So let's see what that process looks like. To examine the running process on a system, we can use the Linux underscore ps list plugin. So let's use that plugin. So as you can see, this plugin doesn't just list each process name. It also lists the process ID and the parent process ID, which help us determine what is often referred to as parent-child relationship between process. And there are two anomalies that we quickly identify. So let's find that out. Yeah, so here you can see minor. So the process ID is 10280 and the parent process ID is 1. Okay, 10 to 80. We can note that too. Just if it got asked in question because it is redacted here. So now the ELF analyst confirmed they didn't execute the miner process. Based on the program name, our initial assumption is that we may be dealing with a crypto miner. A crypto miner, short for cryptocurrency miner, is a computer program or hardware device used to mine cryptocurrencies. Okay, and the MySQL server appears to be Benjin, but this is misleading. The real process for MySQL is called MySQLD as listed above. So you can see MySQLD is here. Okay, the ELF analyst confirmed they didn't execute this. Given that the PID of the process is different from PPID of the miner process, this process did not spawn from the miner directly. So we would like to know more about these processes. A good way to do this is by examining the binary of each process. So we can do this via process extraction. So a good way to understand what a process is doing is extracting the binary of the process, and this will help us analyzing the binary using malware analysis. And we will also want to extract the binary of the process as form of evidence preservation. So we can utilize Linux procdum plugin. So we just need to create a directory to indicate where we would like the extracted process to go. Okay, so let's create a directory named extracted. Okay, mkdir extracted. Now then we will utilize the D flag to tell volatility where to place the extracted binary and indicate the process's PID with the P flag. Let's copy the command, and our PID was 10280. Yeah, you can see the process name is miner and output file is extracted miner. Okay, now we will do the same thing for a MySQL server. So we just need to change the process ID. So this time the process ID will be 10291 for the MySQL server. Yeah, so both the binaries are extracted. You can see that you can see binary for miner and binary for MySQL server. Let's go ahead. So now we have successfully extracted a suspicious program into the restricted folder. Having heard of the commotion, Skiddy offered to help with investigation by taking over the operations threat intelligence task. And for that, Skiddy needs the MD5 hash of the each extracted binary, which can provide with the following command. So we can just use MD5 sum command to get the MD5 hash of both these files. Okay, let's see. File extraction. So as stated above, we want to look at any cron files that may have been replaced by the malicious actor or crypto miner. This can help us identify if there are any persistent mechanism at play. Okay. So but how can we enumerate files on the server? We can utilize the Linux underscore enumerate underscore files plugin to help us with this. And the benefit of this plugin is to help us review any file of interest. And the plugin's output will be too large, so we can utilize the grep utility to help us focus our search. Okay, so just minimize that, and we can only search for paths which contain cron. Okay, so let's do that. Okay, so the command has ran. So you can see every path every file which contain cron is listed here. You can see where is full cron tab, and then we have cron tabs and LP. So this look interesting. So we quickly define the cron tab located in where is full cron tabs LP. We speak to the ELF analyst to confirm they didn't have any cron job set up on the server. So now we can now extract the file by selecting the inode value, which is the hex-like value located to the left of the file name, and using the -o option to name our file during output. Okay, let's do that. Okay, so it's Linux find file. Then we need to give inode value, which is this. Copy this. Okay, then we need to give the output name. Let's give same like here, LC, capital O, I think. So now it will extract this file. I think it's done. Let's do ls and check. Yeah, so you can see a file with named alpha is here now. So go ahead and examine the contents of the LFI file using the cat LFI command in order to understand how the MySQL server was placed. And with all the overwhelming evidence, Blue decided to move the incident following the company incident response and incident management process. So the next question that arises from this incident is, are the pipelines safe? So are they? Let's see the questions. So what is the exposed password that you find from the bash history output? So you can see the password for MS SQL was exposed. Yeah. So what is the PID of the minor process that we found? We found that it was 10280. Okay. What is the MD5 hash of the minor process? So let's check that. You can go to extracted. So we need to check for minor. So we will use MD5 sum. So yeah, this is the MD5 hash. Now what is the MD5 hash for the MySQL process? So we will do same thing. MD5 sum for MySQL process. Now use the command strings extracted minor PID from question 2. Okay. And then grab HTTP. Okay, so let's do this. One zero two eight zero. We don't need extracted because we already are in extracted folder. Okay, let's see. So we have http MacReady secret c2.thm, and one more is invalid lookup. So this one looks suspicious. What we need to give? Okay. Okay, let's copy this. Okay, it also says fully define the URL using CyberChef. So let's open CyberChef. Okay, defang URL. Yeah, so let's see if this works. Yeah, correct. So after reading the LC file, what location is the MySQL server process dropped in on the file system? So let's read the LC file. Let's clear the terminal. Let's go back. Now we can read the LC file. Okay, so the location is var tmp system.python 3.8 updates MySQL server. Okay, yeah. So that was it for day 19 memory forensics. And if you enjoyed this task, you can always check out the volatility room to more about this tool, how to install it, and the other benefits of this tool. So that's it for this video. I will see you in next video. Till then, keep learning.